Yes, there we have the 2 medical minutes. So, hello and welcome to this webinar with the title Blockchain Technology Enhancing the Future of Software Testing. My name is Magnus, and I will be the moderator during this webinar. I'm a quality assurance specialist and a test evangelist here at System Verification, and I've been working for System Verification for 30 years and within the Q&A for almost 30 years, something like that. It started out when I got my PhD in software engineering, and that kind of woke or started my interest for software testing and QA. But during that time and along these 30 years, I learned that I don't know everything, and that is an important insight, I would say. So webinars and educations courses is very important from my point of view to be able to stay or be in the front line. And we at System Verification, being the leading QA company here in Sweden, we focus a lot of education and knowledge transfer. So therefore, I am very thrilled to learn more about blockchains today, but we will soon come to that. But if you are interested in learning more about how we work with, for example, AI and other interesting technologies or our offerings, please feel free to read more about them on our websites. Down below here in the window, you can find a link to the site. But if we go into today's topic, blockchains, mostly they have been associated with cryptocurrencies, but it started already in 1982, where the first protocols for the blockchains were presented, and it started to grow. But it could say that it took off in 2008, and after that, it has been applied in a number of other areas and domains as well. And this is what Grace today is going to tell us more about in this webinar. Grace is a consultant here at System Verification and started with us almost a year ago. And she has solid experience in back-end automation testing and ranging from fintech to, of course, blockchain technology. She also is interested in home automation and tech psychology. So that could maybe be another topic later on. But focus today, as I said, blockchains and the enhancing of the future of software testing. So if you do have any questions, please feel to write them in the Q&A tab during the webinar here. And afterwards, there will be a Q&A session where we will try to answer your questions. So enjoy this webinar, and the stage is yours, Grace.
Thank you. Before we start, we would like to share a poll just to get an understanding of your knowledge on blockchain. So there will just be a poll in a minute where you can answer your knowledge on blockchain. If you're familiar with it, if you're not familiar at all, or if you know a bit of blockchain. Okay. We can begin. Okay. I will share my knowledge of blockchain, emphasizing on various concepts within the technology. I will also share 2 reasons why you should use blockchain technology in your current work. To wrap it all up, I will show an example of how a transaction is sent on a blockchain. Throughout the session, I will use an analogy of a notebook to ensure better understanding. So let's begin with some definitions. You can think of a blockchain as a secure way of storing data. Blockchain technology is you could say it's a collection of methods by which data is stored in blocks to ensure its security. Nodes are participants in a blockchain network, but they are basically any computers that connect to the network. Okay, so now we'll talk about a block. Keeping that in mind, you can think of a block as a page in a notebook. A block is a collection of records, and it has three primary elements that I think you should know. You have data of transactions, a hash, and the hash of the previous block's data. Data of transactions captures a list of all the transaction activities that happen on a blockchain, while a hash can be seen as a unique or distinctive identifier that ensures authenticity and distinguishes one block from another. Each block has a unique hash. No two hashes are the same. To sum it up, just as a notebook is made up of individual pages that hold information in sequence, a blockchain is a series of blocks, each holding data and connected in a verifiable chain, one after the other. Another concept is nodes. Nodes in a blockchain are not people, but computers, servers, or devices operated by individuals or organizations. Each node runs the blockchain software, enabling it to perform critical functions within the network. You can think of each node as a custodian of a detailed checklist that includes all past and pending transactions. When a transaction is initiated, nodes work to verify its accuracy and legitimacy according to the rules of the blockchain protocol. If the transaction passes this verification process, it is then added to the ledger as a new block. This process ensures that the blockchain operates without the need of a central authority. Sorry. Okay, so now we'll talk about the consensus mechanisms. These are some of the methods utilized in blockchain technology. I mentioned them in the first slide. So, what they do is that they ensure that every participant in the network adheres to a standardized version of the truth. So, there are many consensus mechanisms, but the two primary types are proof of work and proof of stake. Proof of work is a method that requires participants to solve complex mathematical problems. An example of a proof of work blockchain is Bitcoin, and then you have proof of stake. This method allows participants to create blocks based on the number of coins they hold. You have Ethereum is both proof of work and proof of stake. It's in the process of moving to proof of stake, but that's an example of proof of stake. So, using the analogy of a notebook, I can now paint the whole picture for you. Blockchain technology is comparable to the entire notebook. Each page within this notebook represents a block. The nodes act as the binding that holds these pages together, ensuring they remain in sequence. The rules for writing in this notebook are the consensus mechanisms. So that's how everything works together, hence forming blockchain as the technology. Okay, so we have several types of blockchain, but today the focus will be on public blockchains. This is because my experience is mostly with public blockchains. They are open and decentralized networks where anyone can participate. And as of now, you know that a good example is cryptocurrencies. With the necessary technical expertise, anyone can create a cryptocurrency as long as they follow the rules and techniques of the blockchain. So each blockchain has different rules, techniques, but methods are pretty much the same. And one of the methods I mentioned was consensus mechanisms. Okay, so how can you use blockchain as a tester? Most companies utilize services like AWS or Azure DevOps. Consider a scenario as a tester. You need, let's say you need a feature tested by Monday. So you initiate the test on Friday, but a brief Azure downtime over the weekend causes them to fail. So this forces you to rerun the test, which adds another 2 days to the process. In contrast, the decentralized database of blockchain distributes data across multiple nodes. So what this means is that if one node fails, all the others will continue to operate. So this will ensure that your tests are completed on time without any server-related interruptions. So at least that's one thing. If you use blockchain, you won't have to worry about. So, after obtaining your test results, you might need to refer to them months or even years later. So, secure storage is crucial. While someone with access to Azure could potentially alter the test results, blockchain immutability ensures that such changes are impossible. This guarantees the authenticity of your test result history. Okay, now we will go to, I will start talking about my experience. So in blockchain, I have, like I mentioned, I have experience in public blockchains, mostly doing REST API testing. It has included both traditional, functional, and integration testing, as well as specific node and state testing. These specialized techniques are crucial due to the decentralized nature of blockchains. You need to ensure that individual nodes function correctly and that the overall network maintains data integrity. Yeah. So now let's talk about tooling. These are the three tools I've interacted with, but it's good to note that there are more tools depending on the blockchain structure, system, and the testing that you're doing. So I have used Postman, which is an API testing tool. Blockchain Explorer, which I will show in the demo. It's a web interface that allows you to check transaction data on a blockchain. Then you have faucets. They're basically sources of free test coins. Each blockchain has one, and the amount you can get depends, it varies on the blockchain. Yeah. So it's a bit quick, but now it seems like we are at the stage of a demo. So before I start the demo, I would like to introduce what I'll be doing. So the blockchain I'll be using is Algorand. It's worth noting that in public blockchains, transactions typically incur fees. These fees are collected as a reward by the validators or miners who are responsible for processing the transactions and securing the network. I touched on consensus mechanisms earlier. Algorand utilizes a proof of stake mechanisms, which ensures that fees remain low and stable. In comparison, blockchains that rely on proof of work mechanisms frequently face high and unpredictable fees. So if I was testing on Bitcoin, the fees would be pretty high. That's why I picked Algorand for demo testing purposes. In the demo, I'll show you how transactions can be seen on the Explorer and how the transaction is sent on Algorand blockchain. You can directly do this by installing the blockchain client and using the APIs provided in the documentation. Each blockchain provides detailed documentation. However, for today's purposes, I will use APIs provided by a third-party company that makes it easier to build blockchain apps without having to install the client. Okay, so I will just share my screen. Okay, just a minute. Okay, so this is Postman. So I already have the tests imported. So this is the test scenario that I was talking about. So basically, in all blockchains, you need an address, which you can think of it when you go to a bank and open a bank account. You would need login details and a password. So your address is like your identifier, and then you have a private key, which you can think of it as a password. So it's like your secret. It's how you access how 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 it's links to your address in simple terms. Let me just say that. So for starters, so I mentioned that I'm using a third party service, but it's good to mention that if you are actually using this, like you had the blockchain client downloaded on your machine, you would still need to generate a wallet. So you the important note thing to know is that you need an address and a private key. So this is what this first request is doing. So when I send the request, I will get an address. The secret is usually the private key, and this is about account management. So it may not be relevant if you're using a blockchain client, but this is relevant because again, we're using a third party service. So this is more of account management. Just in case I lose my address or my private key, the company is able to recover my account using this phrase. Okay. So once we have the address, the next, so these two steps are also again tied to, because we're using a third party company. Normally, you would just generate an address, get the private key, find the address, and then do the transaction. But we have to do these two steps to link the address that we created on the blockchain to the company details that we're using. Okay, so I'll just fast forward these two steps. Okay, okay. So yeah, like I said, so this is the same address that we generated on the blockchain. It's just linked to my account ID provided by the company. So just to confirm, we can go to the first request and just, you can see that maybe I can, hopefully you can see my screen. But you can see that this address is the same one. So as earlier I was talking about an explorer. When you go, so mostly it's information on Google. You can just find, so we're working on blockchain, so we're working on Algorand as a blockchain. So you just do Algorand Explorer. This is testnet. So there are two networks, it's either testnet or mainnet. Um, and then you would basically, it would be the first link, because the same company that does the Explorer should be the same one that will provide the faucet and also the documentation in most cases, not all the times, but in most cases. So we have an address, so we can just paste that, and then it will show us the current status of our address. So we basically have no assets, which is okay, but like you can say that the address has been registered on the public blockchain. Okay, so the next thing would be to find our address so that you can see that the data it gets updated. So same thing with the faucet. You just do the same way that I searched for the Explorer. It's the same way you would search for an Algorand testnet faucet. It's very important to remember the networks that you're working on, because mainnet actually use actual coins that you need to have. So in that case, you would need an actual wallet like MetaMask or Exodus, the different kinds of wallets. Yeah. So when you dispense, they should reflect. We just go back to the Explorer, refresh, and then we should be able to see that it has updated from 0 to 10, and you can see the transaction here. So we go back to our tests, and then the next thing, so this is also an API that has been provided. It's the same thing that we have done manually on the Explorer. We can also check the balance on Postman. If you're writing tests, this can also be, you can include this request as a check if you want to check if the balance actually synced from the public blockchain to the to because we're using again a third party service. So yeah. Okay. So now we can go to actually doing the transaction. So, uh, as I mentioned, all public blockchains have something called a fee. This is mandatory, it's required, it's something that you can't really avoid, but you can manage the expenses based on if you're using a blockchain that uses proof of stake or proof of work. Okay, so a note is like basically how you would write a message if you're sending money through a bank. And then the from private key is what I mentioned earlier. When you generate a wallet, you get an address and a from private key. And then two is just another Algorand blockchain. So you can send if you're working on Algorand, so I can only send transactions to another Algorand address. So everything is already set and it's correct. It's the same address that we are using. This is just parameterized for testing purposes. So if I click send, so the amount to send is 1. This should also reflect on the public blockchain. Okay, so what you get is a transaction ID, which is basically a confirmation that the transaction has happened. We don't really have to search, but we can search with it. As you can see, it has already reflected, but you can just use it so that I can show that the transaction ID actually works. Yeah, and it tells you that the amount sent is 1. So if we go back to the actual address, you can see that the block has been registered, the transaction also has been registered, sorry, it's the first one, has been registered to the block, and that the fee that I mentioned for Algorand, this is a standard fee, it never really changes, it's stable, like I mentioned before. So yeah, that's basically it. Yeah, I think that's the presentation for today. Um, we have a poll that we would like you to answer if you, yes. Did you learn anything new? Yeah.
Yes, thank you very much, Grace. So while the poll is up here and the participants here are answering, I have a few questions for you to start with, which we have received here. So the first one I would like to start with is in which industry is blockchain technology most applicable, do you think?
Okay. So I would say, so it's good to know that blockchain is not for every industry. It depends on which industry you're in. So the ones that are most applicable to blockchain would be automotive, banking, healthcare, or supply chain management. Yes.
But not restricted. So you might come up with other areas applications as well. But going thinking outside the box, maybe. Yeah.
Yeah. Yes. So it depends on your need, but it's basically if you need to secure data, then you would need blockchain
Okay.
technology.
Yeah,
Yeah.
okay. But then, if we're talking about the blockchains, do you see some limitations of the blockchain technology?
Yeah, I did mention that blockchain has a, especially, let me be specific to public blockchains, they have they're transparent by nature. So if you're not very comfortable with your transaction details being public, privacy might be an issue for you. But that's why you have different types of blockchains. So where transactions are Like you don't want the data to be public, then you would go for a private blockchain or a federated blockchain, the different types of blockchain types. Yeah, that's one limitation. Another one would be consumption. So the consensus mechanisms I mentioned. So like Bitcoin, a works on proof of work, which is very energy consuming. It needs a lot of computational power. So it may not be good for, it is not good for the environment actually, but it's still being used. But most blockchains are trying to move away from proof of work to proof of stake. So that's another limitation of blockchain.
Okay, okay, yeah, interesting. Yeah, I've heard about the when you talk about mining bitcoins, you actually do need to mining some coal or something like that in China to be able to get all the energy you need for the servers to mine the new blocks there.
Yeah.
Yeah. Okay. But that's that's a slightly different topic the environmental aspects. But then the question, more a broader thing that came here. So why do system verification see blockchain as a natural part of their portfolio? So why are we focusing on this?
I would say that there's some we have some assignments that actually use blockchain technology in Sweden. One example would be for to keep patient data safe. So that's one of the reasons it's a technology that's rising and it's becoming a necessity to be used in our current assignments and also in future assignments. So that's why as a company we're interested in learning more and different ways on how we can include it more in our everyday processes, as well as also thinking about AI at the same time. Yeah.
Um, another question here. So, is if you could explain proof of stake mechanism in a more details, or if you have some examples about this.
Okay. Proof of stake is, like I mentioned, it's about how many coins you have. So basically, I can use an example. So what happens is that let's say you this one is in terms of cryptocurrencies. So let's say on Algorand you have like a million coins. So you can register your address on the blockchain to be a validator. So what happens? Everything happens automatically. So it's not like you have to do anything new as a user. It's just the system is able to identify, okay, this address has a million coins, so we can add this address as a validator. So if your coins are on an exchange, exchanges have something called you can register um, to like stake your coins. So it's basically putting your coins away for a while. Like you won't touch those a million coins. So they're going to be used to validate blocks on the blockchain. All this happens automatically, and it's basically, yeah, like I mentioned, you need to have a significant amount of coins. Yeah, I don't know if that answers the question.
Yeah, that's. I hope so. If not, we can maybe come back to this one.
Yeah.
But meanwhile, there is another question here. So, how is the uniqueness of hashes ensured? Does the implementations vary from blockchain to blockchain, or is it the same?
No, the implementation doesn't vary, and the hashes are like computed automatically. Again, it's with the blockchain software. So these are it's like it's a concept that's mandatory in blockchain. Like it's not something that a blockchain determines for itself. It's the blockchain technology provides these methods. So it's not something that Algorand will decide, oh, we want a shorter version of hashes or we want a longer version of hashes. They're all the same hashes, but done in a way that they never repeat, and they are always unique. So it's this blockchain software that does this.
Okay, yes. But then could there then be different variations in the implementations, or is it always the same that you provide this uniqueness for the hashes then?
This is on public blockchain. So on
Mm,
private and federated blockchains, yes, they
mm,
would be, because now is it's for you to decide how you want the hashes to be. But in public blockchains, no, I would
mm.
say.
Okay,
Yeah.
okay, thank you. Okay, yes, I don't haven't received any more questions. So, with that said, I thank you very much, Grace, and all you participants for taking part of this webinar and for providing questions here. And as I said, if you would like to learn more about what we can offer, please feel free to visit our website. And you can, of course, also reach out to Grace afterwards if you have more details or specific questions. So thank you very much, everyone, and have a lovely day.